So hello and welcome back to the channel guys, and this is the date 1/1/2024. So today it's a happy new year. So I am wishing you a very happy new year, one and all, to all my followers, to all my students. This new year brings lots of happiness in your life and you achieve your goal, especially my NEET and JEE students, for board students also, for their board exam, all the best, and very happy new year once again. So uh, so new year celebration is going on. Hope you people enjoyed the celebration. That is okay, but study should be carry on. There will be no distraction in the study. In the last video we have discussed about the properties of D and F block. Lecture number 2 is already uploaded in the channel. Now come to the lecture number 3. In that case, till the till here you can check this table. Last turn I discussed here atomic number for the first transition series, which is your 3D series. 3D series: scandium, titanium, vanadium, chromium, manganese, ferrous, iron, cobalt, nickel, copper, zinc. So ionization, enthalpy of atomization, mm, metallic and ionic radii, standard electrode potential, and all thing is given. Now the next property is trends in m plus 3, m plus 3, m plus 2. What is m plus 3 and m plus 2? Standard electrode potential, that we are going to discuss. So what is written here? Point number one is the low value for scandium. The low value for scandium reflect the stability of plus 3 oxidation state, which has noble gas configuration. What is this? What they are saying: the low value for scandium reflect the stability of scandium plus 3, which has the noble gas configuration. The highest value for zinc, what they have given, the highest value for zinc is due to the removal of an electron from the stable 3D configuration and converted into Zn plus 2. The comparatively high value for manganese, so that particularly stable, whereas comparatively low value for Fe, so the extra stability of d5 orbital. So you can check this thing here. In the case of oxidation state, where is the oxidation slide? This one. Here plus 3. In the case of zinc plus 2. In the case of manganese plus 7. Iron plus 6. That is the condition. Once again check it. What is written here? All the things you have to read out once again. I'm clearing the screen now. The low value for scandium plus 3 oxidation state 2 plus 2 oxidation state standard electrode potential. The low value for scandium, which has the noble gas configuration. Similarly for zinc and manganese. Now the trends in stability of higher oxidation states. The highest oxidation number are achieved in TiX4 tetrahalide, like VF5 and CrF6. The highest oxidation number are achieved in this titanium tetrahalide and VF5 and CrF6. The ability of fluorine to stabilize the highest oxidation state is due to higher either higher lattice energy in the case of COF3 or higher bond enthalpy terms for higher covalent compound. Example V2O5, VF5 and CRF5. So check it this once. Oxidation number plus 6, oxidation number plus 5, oxidation number plus 4. So these compound plus 3. So that is the plus 2 is the more stable and plus 1. X fluorine, okay, X dash, so that is the condition for trends in stability of higher oxidation state. I hope it is clear to you. Oxidation state, okay. Next, another feature of fluoride is their instability in the low oxidation state. Bx2, chlorine, bromine or iodine, and the same applied for Cux also. Cu plus 2 oxidizes to um, plus 4 iodine, that's CuI2 plus I2. Copper compound are unstable in aqueous solution and undergo disproportionation reaction. Check it. Here plus 1 oxidation state, here plus 2 oxidation state, here 0. So plus 1 to plus 2 oxidation, plus 1 to 0 reduction. The stability of Cu plus 2 rather than Cu plus is due to the much more negative hydration enthalpy, hydration energy and Cu, which more than compensates for the second ionization enthalpy of Cu. Chemical reactivity and E value. Chemical reactivity, the E value for M plus 2 to M indicates a decreasing tendency to form divalent cation across the series. E naught value for M plus 2 to M plus 2 to M indicates a decreasing tendency to form divalent cation across the series. This general trend towards less negative value is related to the increase in the sum of first and second ionization enthalpy. The E naught value for manganese, nickel and zinc are more negative than expected from the general trend, whereas the stabilities of half-filled D and completely filled D subcell in zinc are related to the E naught value. For nickel, E naught value is related to the highest negative enthalpy of hydration. So these are the theoretical points you have to focus on it. Based on E naught value for the redox couple plus 3 to plus 2 shows that Mn plus 2 and Co plus 2 ion are strongest oxidizing agent in aqueous solution. The ion are strong reducing agent will liberate hydrogen from dilute acid. So this is chromium acidic solution. So hydrogen gas will be liberated. Okay. Magnetic property, that is the important one. Magnetic property. So children, when a magnetic field is applied to the substance, means d block element, mainly two type of magnetic behavior are observed: diamagnetic and paramagnetic. Diamagnetic substances are repelled by the applied field, while paramagnetic substances are attracted. Substances which are attached very strongly are said to ferromagnetic. Substances which are attract very strongly are said to be ferromagnetic. Paramagnetism arises from the presence of unpaired electron. If so, it is very simple. Paramagnetic paramagnetic means unpaired electron. If unpaired electrons are there, then paramagnetic. Diamagnetic, repulsion. They will show repulsion. That means all electrons are paired. No unpaired electron. No unpaired electron. Okay. So that is the magnetic current. If unpaired electron is there, then that will be attract. Paramagnetic substances are attract. In diamagnetism, repel. Okay. The magnetic moment is determined by the number of unpaired electron, and it is calculated by using the spin only formula. Mu is equal to under root n plus 2, where n number of unpaired electron, n is equal to number of unpaired electrons. Mu is the magnetic mu is the this mu is the magnetic moment in unit of Bohr magneton. What is the magnetic moment unit? Bm, Bohr magneton. The magnetic moment is increases with the increased number of unpaired electron. If number of unpaired electron increases, magnetic moment also increases. Okay. One more formula I am telling you. Mu is equal to under root 4s s plus 1, where s is equal to n by 2, where s is equal to n by 2. Okay. So scandium, how many unpaired electron? 1. So magnetic moment of that will be under root 1 1 plus 2, so 3, that is under root 3, under root 3 1.4 something. So that is the calculation of magnetic moment. Formation of colored ion, that is very important. Formation of colored ion, check it once properly. Formation of colored ion: when an electron from a lower energy d orbital is excited to higher energy d orbital, the energy of excitation correspond to the frequency of light absorbed. The color observed corresponds to the complementary color of light absorbed. Color is due to the presence of incomplete D subcell. Many transition metal compounds are colored due to incomplete D subcell. So example, suppose 26 Fe. So what is the electronic configuration? Ar 3d6 4s2. Okay. So in that case, d orbital 1 2 3 4 5. So this is your d orbital. So what happened in that case? Here lower energy level, here higher energy level, it's called Eg, it's called T2G. Okay. So how many what are the cell here? DXY, DYZ, DZX. It is DX square, Y square, and DZ square. So that is depend upon the Y color is showing D transition, DD transition. So basically color depends upon unpaired electron, nature of ligand, geometry of complex. So color of the compound depends upon number one, unpaired electron. Color depends upon unpaired electron. It is depends upon nature of ligand attach and geometry of complex. So you can check when electron, what is written, when an electron from a lower energy d orbital is excited to higher energy d orbital, the energy of excitation correspond to the frequency of light absorbed. The color absorbed correspond to complementary color of the light absorbed. Color of the sum of the first row transition metal ion 3d0 configuration scandium plus 3 colorless. You can check scandium titanium different electronic configuration and their colors are given. You can take the screenshot, and I think this table is present in NCERT also. Maybe check it once. Okay, so till here we have covered, and remaining in the next lecture we will discuss. So that is it for this. Thank you everyone, and all the best, and again happy new year.